Good afternoon, everyone. We were told we only had 12 minutes, so that means I get to sort of like expand. So just use a big hook to pull me off when I should be done. So the reason I'm asking this question, how should we think about and study copper-based assemblages in Southeast Asia, has to do with the recent, almost finished Penn Museum monograph on the metallurgy of Ban Chiang. And you can see here it's 4 3/8 inches thick, single-sided. And this is the Philadelphia team. Arneth Anderson has worked for me for many years in terms of illustration, graphics. Elizabeth Hamilton, you'll be seeing more of her. She is our archaeometallurgist. And so this is very much a team project. We also have chapters. If I'd known I had a lot more time, I would have put the table of contents up. Vincent Piggott is doing a section on the production, and Ollie Price on the sourcing, but most of it is Elizabeth and myself's work. And so I've had a lot of time over the past, really, more than 10 years to think about what do we do with metallurgy samples in our assemblages. Very timely, this has become a hot topic. I did a paper on archaeometallurgy in 1988, and I thought, well, that's it for my career. There's not that much there to do anything about metallurgy. But over time, the field has really shifted from a very backwater, very technical field into a much more interesting craft, production, social, economic network type things. And metallurgy provides some of the very best evidence in archaeological assemblages for technological development and social interaction and economic development. So it turns out to be an incredibly rich data source for the kinds of questions archaeologists are asking today. And this particular book, Archaeometallurgy in Global Perspective, which was published in 2014, sort of has turned the page in archaeometallurgy studies and brought it into the mainstream of anthropological archaeology. Several trends were noted by the editors, Ben Roberts and Chris Thornton, and I want to focus on, topic number 4, all material remains from ancient technical practice must be analyzed. So, what does that mean? And most of my talk will be about that. I want to say that this point of view is essential for the two kind of fundamental theoretical underpinnings that are currently discussed nowadays in craft manufacture, production, economy. And these two themes are the life history framework and the Shen Apertoire perspectives on the manufacturing portion of life history. This will all become clearer as we go forward. So what are the tasks in a life history approach to an assemblage? First, number 1 is, as Ben and Chris pointed out, assessing whole assemblages, building a regional picture, and documenting and evaluating variability. In the process of putting the monograph together, we had a chapter whose title evolved over time and finally became the Geomorphology of Metal Resources in Southeast Asia. And this was really a revelation to me as we worked through trying to figure out what were the real geological resources and what was the underlying geological processes that created those resources. And this puts, in my view, the Southeast Asian metallurgy in a whole new perspective. Unfortunately, haven't mastered how to put a video in a PowerPoint yet, but the essence of metallogenesis is the interactions of plate, not just plates, but plate fragments or terrains, as they bump into each other, pull apart from each other, twist against each other, override, underride, those plate interactions create, in some contexts, magma. And when you have magma, you're most likely to develop metal ores of particular genres, such as copper and tin. Not uniformly, not universally, but the geographic regions in the world where there's a lot of plate interaction are geographic regions that have the potential to be very rich in metallurgy, or metal resources. And Southeast Asia is one of those regions. And so you can see here, when you get into the primary literature, it's incredibly complicated. So this is kind of a summary view. And you can see that, where the Ban Chiang region is in northeast Thailand, it is actually surrounded by two major fold belt systems. The Loei fold belt system here and the Trung Son fold belt system here. So it is kind of amazingly positioned just with respect to plate tectonics. But how does that spin out in terms of actual metal resources? And you can see that here. Now, there are many plates and plate fragments interacting. So there's actually 5 metallogenic belts recognized in Southeast Asia, mainland Southeast Asia. You have the Burma-Malay belt. You have what I already said, the Loei belt, the Trung Son belt, Lower Mekong belt, and the Red River belt. The Loei belt is particularly rich in copper resources. And this is modern day copper resources, but just, significant ore presence. And the Trung Son belt, very interestingly, is a significant mixture of both copper and tin. So there are not that many parts of the world where tin and copper are in such close proximity to each other. And not that many places in the world where you have a society, a metal-using society, that is within 200 or 300 kilometers of both resources. So that's, in Ur, for example, in Mesopotamia, the closest tin might be 500 kilometers away, and they've only kind of recently discovered this source. They're not sure if it's been used prehistorically yet or not. Another source is 1,000 kilometers away. So this very close proximity is highly unusual in this region. Now, while we're on this slide, I just want to point out a few things. There's 3 copper production areas that have had significant archaeological research. One is in the Lopburi area, the Kowloon Pachon Valley. Second is Pulon, right on the Mekong on the Thai side. Sepon in central Laos. So we have you're starting to get a pretty good understanding of the copper resources that were actually exploited in prehistory. And I want to add one area that has not been studied yet, and this is the Kowloon tin deposits, which are right here, just basically due east of Ban Chiang. We don't know, we haven't studied them yet, we don't know if they were exploited in the past or not, but it seems highly suspect that they were. Oops. Okay, sorry. Okay. So, the monograph is about not only the metal remains from the site of Ban Chiang, but also from 3 sites excavated in 1975 at the same time. Also in northeast Thailand, we have Ban Dong, Ban Phak Do, and Dong Klang. So the monograph is a regional study incorporating evidence from 5 excavations at 4 sites. And you can see here that we have the assemblage of metal remains is about 640 objects. And we have 63% from the 2 excavations, 74 and 75 at Ban Chiang. Dong Klang adds a sizable number, 102, Ban Tong, 116, and Ban Phak Do just a few. Whoops. Copy. Putting away all my goodies. Okay. So, what is a whole metals assemblage? Of course, we are all familiar with the intact artifacts. And many artifacts that are broken may be identifiable to function or type. But really, the key thing here is every other piece of metal, regardless of condition or context. And all metals-related byproducts, manufacturing equipment, and installations. What do we do with a whole metals assemblage? What do we do with the fragments that are not identifiable to function? Well, like many Metal Age sites in Thailand, the intact artifacts are kind of what people are focused on, but the vast majority, in the range of 80%, is a large group that for the first several years of the analysis we had in drawers labeled detritus. Copper-based detritus and iron-based detritus. And they were, perhaps weighed or something, but more or less ignored. That was until, in the 1990s, a work-study student, undergraduate, and any undergraduate who thinks that they won't have an impact on research, this is a good counterexample, Alyssa Hinckley, who had taken one of Vince Piggott's archaeometallurgy courses, said that, actually you could do a much better job with the detritus portion. You can differentiate, for starters, between the deliberately shaped pieces and the pieces that show no deliberate shaping. And then the deliberately shaped pieces can be differentiated based on form, which could have some potential relationship to function. So she divided and reclassified the entire detritus class as follows. Curved fragments that are generally in the curvature of other bangles could be assigned to the bangles. Thin, straight pieces with different diameters could be assigned to wires or rods. Whoops, gosh, this is very sensitive here. Okay. Flat pieces can be flat. And amorphous is lumpy, no evidence of shaping. The amorphous is particularly important. These are considered likely to be drippings from casting operations. So study of these amorphous will give you some sense of what metals were actually being cast on site. And when we look at proportions, items identifiable to an actual implement are less than 10%. Identifiable artifacts, bangles are the highest proportion. Wire rod flat, substantial proportions, but the largest category is the amorphous. So we look at the distribution of the amorphous, we have metallography of the amorphous, so we make commentary about the manufacturing based on this amorphous category. When we look at context, grave goods are, in the total corpus, only 10%. Although this says burial associated, it's stuff near burials, not grave goods. And when we look at the composition, it's basically the same as the general soil matrix. So it's material that's been redeposited in with the grave. And that is our whole metals assemblage. When we look by site, we can see Ban Chiang has 15% of copper-based artifacts or grave goods. A good hunk, half of the rest about, are shaped but no mortuary context, and then another half are amorphous. Similar to Ban Pakto, Ban Thong, Ban Klang, they did not have copper-based artifacts as grave goods. And then Ban Wat, by way of comparison, 7% in the Bronze period were grave goods, but you can see, even though they didn't differentiate amorphous or deliberately shaped, basically the same things going on there. It's very sensitive. Okay. Okay, so the technical studies actually help you with the chaîne opératoire aspects in particular. I'm sorry. And we did a thorough study. We have 33% of the copper base assemblage was studied metallographically, 10% sample of elemental analyses, mostly Pixie, and just a pilot study level of the lead isotope, 2.7%. But this is the most thoroughly studied archaeometallurgical assemblage in Southeast Asia that we know of. I'm probably running out of time. Okay. Metallography is the backbone of archaeometallurgical studies. Although it is particularly informative on formation, you can get some elemental information. And this gray stuff here, if you see this kind of formation, you know that it's at least 5% tin, a good solid bronze. But formation or squished 5 minutes, okay. Squished dendrites will show that it's been hammered, and there's other evidence that shows annealing or heating. Unbelievable. Very sensitive. Long way to the conclusion. Speak about 20 slides. Okay, I'm just going to skip along. Okay, so the key thing from the elemental analysis is that most were alloyed, tin bronze. There's a little bit of occasional antimony or arsenic, but 4 were impure copper, a very low percentage, mostly the flat and wire rod. Unusual alloys with antimony or arsenic are usually in the early periods, suggestive of experimentation of alloying at that time. The lead isotope is really interesting. We have here the Kowloon-Fuchun Valley signature. The yellow is the Pulon signature, and the red is the Sepon signature. And 3 of the Ban Chiang artifacts fell within the Sepon signature here, and the rest no particular signature. The ones that lined up with the Sepon were some of our earliest metal artifacts. It included the bent tips bronze spear point from Barrow 76, the earliest grave good, copper-based grave good excavated from the site, and slightly later some of the bangles with the variant named Vulcan. So, very early relationship between Ban Chiang and Sepon. Why is this interesting? Well, for one thing, the Ban Wat early copper-based artifacts are copper, not tin bronze, and their signature lines up with the Kowloon-Fuchun Valley. So all of a sudden, we have coming into resolution specific economic exchange networks and technological networks that are quite distinct. So I think you can see that this is basically my conclusion. A much more expanded and continuing along this line of research and this line of detailed analysis, we will be able to see a lot about who's interacting with whom, when, how it changes over time, and really get a very rich sense of the social networks and economic and technological networks of ancient Thailand. That's it. Any questions? Jade?
Sure, I have a question. So where some of those metal artifacts look quite similar to some stuff that we have in China, and I'm curious because I'm not terribly familiar with Southeast Asia. Do you have a hypothesis in size direction that you think some of these early centers may?
What a controversial question to ask.
Okay. I have no idea. Yeah.
I published with Elizabeth an article called "The Transmission of Early Copper or Bronze Technology to Thailand: New Perspectives." And basically, my hypothesis is that there is a connection with Central Asia, and it skirts along the eastern edge of the Himalayan. It bypasses the Central Plains of China, and much fighting is going on about this, but that's my hypothesis.